book, you have to refer to chapter number 12. So I basically refer textbook the most. Okay, that is why the notes that you can find under class notebook ni since this semester I am also teaching structural analysis for EC 220 student inshallah. Okay, and I got these notes. Okay, so this special thanks to Dr. Tevan for having this note, and basically this note is actually the summary from the textbook. It is actually the same from the textbook. Okay, from the textbook. So if you have any question, you can also interrupt. You can ask me question. If you have question after this the session class, the class session, you can also text me in using Teams chat. Okay, so basically, as I mentioned just now, so this topic, you should be able to to actually calculate member and moment or internal moment in beam, internal moment in frame. That is the goal for this topic. Okay, and in order to do that, you of course should know, should understand about member stiffness. What is member stiffness? What is distribution factor? So how we are going to calculate distribution factor from member stiffness, and what is actually carryover factor, as well as stiffness modification factor. And then we will apply fixed end moment. Fixed end moment has two category. One is come from external loading, and another one come from support settlement. Okay, so about the basic principle, this is we will analyze. Okay, we will analyze beam. Okay, this is number one that we are going to do, beam. Okay, and then after beam ni divide into two. Okay, beam divide into two. We have beam without delta. Ni without delta and with delta. With delta means with settlement. Sini settlement lah. Settlement. But what we are going to do today, this week, we will discuss on this. Okay. Number one, without delta. Beam without settlement. Okay. And then we have frame analysis, of frame using moment distribution method. We have no side sway frame. No side sway frame ni means without delta for frame. And then side sway means with. Okay, with delta. Side sway means delta. Okay, so this is all about MDM, and we will analyze this to calculate. Okay, what we call as member and moment. Member and moment. So you need to know what is actually member and moments. So that is why I put chapter number 11 just now, because the concept what is actually member and moment, or what is how the member and moment diagram look like has been discussed under chapter 11. Okay, so member and moment. So how many member and moment if we have three span in the beam? Okay, so something like that. Okay, so okay, general principle and definition. Of course, yang ni exactly from textbook. Okay, so proses yang kita akan buat nanti is we will distribute moment. Distribute moment by using distribution process. We do it in table actually to answer beam. Okay, beam or frame, but beam is the easiest lah using MDM. It is very easy because we can formulate it in Excel and we can get the answer directly. Okay, but of course you need to know the principle. So what is the process that you need to do before you can put you can formulate it into the table, and finally the Excel will calculate the member and moment for you. Okay, so this is the idea. So every time we want to do the process, it is actually based on the assumption that n is fixed. That is why we can apply fixed and moment. Fixed and moment. Okay, fixed and moment means this is type of fixed and moment. Means that we have one beam. We have one beam. Let's say this is A, this is B. Okay, this beam has two end. Okay, and both end are fixed. So this is called as, so the moment occur at end A as well as end B is called as fixed end moment. So ada formula lah kat sini, ada formula. So I believe you have learned this previously in diploma as well. Okay, fixed end moment, and fixed end moment is behavior. Fixed end moment is not assumption. The moment direction in fixed end moment is not assumption. The moment direction in fixed end moment is based on the behavior. So this behavior yang you have to understand. Okay, behavior means that due to loading ni, let's say this is 100. Okay, 100 kilonewton. So due to this loading, the beam will bend, jadi bengkok like this. Okay, so moment at A and B, we call it as fixed and moment. We need to put the moment will push back the beam to its original position. Okay, push back to its original position. Okay, the original position is straight. The original position is horizontal. So when the beam is loaded, okay, with any type of any type of loading, maybe point load, maybe UDL, maybe triangular load, maybe point load not at the center of the beam, so the beam will deflect. The beam will deflect. When the beam deflect, there will be fixed end moment. We call it as fixed end moment. Okay, that will push back NA and B. Okay, so that the bend beam will move back to its original position. Will move back to its original position. Okay, that is why the direction of moment have to be like this. Okay, the direction of fixed end moment whenever the beam is loaded like this, okay, must be as stated here, as you can see here, the moment. Okay, because we want to push this to straight position, back to original position. Okay, when we apply moment like this, the beam will move back to its straight position. Okay, straight position. That is fixed end moment. Fixed end moment is always behavior. The moment direction due to fixed end moment, okay, is behavior. So kat sini they mentioned about fixed. Actually, when we analyze beam, when we analyze beam, it may be like this. Loading, okay, loading like this, for example. So we have AB, C, D. So every joint must be assumed fixed. That is why we can apply fixed end moment ni, the formula for fixed end moment. Okay. And the member end moment is actually internal moment. Internal moment. Internal moment. Okay. The principle assuming a joint is fixed. Okay, and then we have to distribute and balance in the table. This process will be done in table form. Will be done in table form. And the process the process is both repetitive and easy to apply. Very easy to apply. Okay, that is why I said just now we can tak appear pula ni. Okay, tak apa. Kita tengok textbook. We can formulate it in the Excel. Okay, so since yang note tu tak boleh ada problem, tak boleh sync habis, kita tengok dekat textbook kejap. Okay, chapter number 12. Okay, actually it is the same. So, nanti boleh tengok nota jugalah, nota yang slide tu. Okay. There are certain things that you need to understand. Especially, okay, these things. Yang ni revision only you dah actually learn this in diploma, and then you have I believe you have learn how to analyze beam. Maybe frame not yet. Dulu diploma pun dah belajar frame. Tapi if I'm not mistaken, your best you only learn about beam analysis in diploma. Okay, doesn't matter. So this is the time for you to enhance back your understanding about this process, because this is very, very important. Especially from this analysis, we can have the moment, the member end moment or internal moment, whereby having the moment we can draw the bending moment diagram directly without having shear force diagram. Okay, before this we learn how to draw bending moment diagram from moment equation, and then we actually can draw the bending moment diagram or to identify moment by using the area of shear force diagram. But the advantage of using this, we can straight away draw the bending moment diagram by analyze the structure or the beam or the frame using moment distribution method. So the keyword here is, okay, not the keyword. This is the important things that you need to know. Okay, before we start doing analysis. Okay, number one is sign convention. Sign convention. Sign convention. Okay, so read this carefully. Okay, it is stated that, okay, we will establish the same sign convention as that established for the slope deflection equation, means chapter 11, where clockwise moment that act on the member considered positive. Jangan ingat yang ni, clockwise moment act on the member, whereas counterclockwise negatif lah, in opposite condition. Okay, yang ni dua ni yang kena ingat ni. Okay, clockwise moment act on member positive. On member positive, clockwise moment. So yang ni yang kena faham. This is the sign convention that we have to always remember when we want to analyze beam or frame using moment distribution method. So what is actually member and moment? Member and moment. For example, we have beam. Okay, beam like this. This is a continuous beam. Okay, continuous beam. Of course, if we check for degree of indeterminacy, the DOI will be more than 0. Okay, let's say we have this. Okay, we have this A, B, C, and D. A, B, C, and D. Okay, a member and moment refers to, yang ni kena clear. Yang ni yang half part dia dah explain dalam slope deflection method tu. So what is member and moment? So we have to draw this beam. Okay, the free body diagram of this beam. We need to divide this into element and into joint. Into element and into joint. So kita nak pecah ikut element and joint. So we have how many element? How many members? We have member AB. We have member AB. We have member AB. Tak cantik kan? Kejap Okay, we have okay, we have member AB yang ni. We have member BC. We have member CD. Okay, member AB, member BC, member CD. Okay, so member and moment means this. Member and moment means this is clockwise moment mentioned under sign convention just now. Clockwise moment that act on member, okay, are clockwise positive. So this is the first assumption that we have to make. Okay, so the orange ni, the orange moment ni, these are all the member and moment. So if we have here A, B, we have BC, we have CD. So how many member and moment that we have for this beam? How many member and moment? How many? How many member and moment? Bilang yang orange ni ada how many? One.
Member 3, moment 6.
Okay, members 3, moment 6. So 6. Okay, 3, 4, 5, 6. So member and moment, there are 6 member and moment for three members. For three members. Okay, members and element is the same thing, yeah. Okay, so we have AB. Okay, member AB, we will have 2N. Member AB, we have 2N. So one element has 2N. One element has 2N. So for AB, we have 2, MAB, MBA. For BC, we have another 2, MBC and MCB. And for member 3, we have another 2, MCB, MCD and MDC. So these 6, okay, these 6 moment are member and moments. Member and moment. So we have MAB. We have MBA. Okay, we have MBC. Okay, we have MCB. We have MCD and MDC. So there are 6 member and moment. And beside members, we also have important element, okay, under this diagram, under this beam. It is join. Okay, it is join. So kalau member and moment ni sign convention is clockwise positive, what about join? Okay, what about join? Okay, we also have, so kat sini lah. So tengah-tengah ni ada join B, tengah-tengah ni ada join C. Okay, sini ada fix A, sini ada fix D. Okay, so the purple tu, yang purple ni is referring as join, as support, as join. Okay, so yang ni, so this is join A, it is fixed support. This is join B, this is join B, this is roller support. This is join C, this is also roller support. And then join D is fixed support. Okay, 4 join. 4 join. Do you have any question? Do you have any question?
No.
Okay, we refer back to chapter 11 ni. I want to show to you. Okay, wait. Loading pula kejap eh. Yang ni pun tak boleh tak appear. Dah appear dah. But still loading. So internet Wi-Fi stuff hari ni not okay. Okay, I want to show to you actually from the textbook under slope diffraction method chapter. Okay. Actually, in this chapter, it shows about join. Okay, join moment. Cannot open lah. Okay, doesn't matter. Okay, so refer back to this. Okay, refer back to this. Okay, what I want to say is, okay, for sign convention mentioned in this chapter yang ni, okay, sign convention mentioned here is about clockwise moment act on member yang ni. Member the keyword is member. So yang clockwise moment ni, dia gang dua ni tau. This is for member only. Clockwise moment act on member positive. Okay, clockwise moment act on member. Okay, actually join moment is opposite with member and moment. Join moment is opposite with member and moment. Okay, yang tu yang ada dalam chapter 11. Join moment. Dekat sini dia dah terus mention about member and moment. Member and moment which actually the outcome that we will get from distribution table. But we need to understand the principle, the basic when this beam we draw the free body diagram, we draw it separately. Okay, we have join, we have members. Okay, we have join, we have members, and the moment for member are always assumed as clockwise, but the join moment is always opposite with member and moment. Means that at the beginning, mana dah yang color mana tak pakai lagi kejap. Hitam lah. Okay. So dekat join tu always opposite. So dia akan opposite dengan orange tu. Yang ni opposite. Dekat B ni opposite. Setiap satu ni dia opposite. Okay. So yang kat sini opposite dengan yang ni dia, yang dekat nombor 4 tu dia kan clockwise kan. So dekat C tu dia lawan dia. Okay, dekat number 5 tu dia clockwise. So dekat C for join dia akan ada satu lagi moment lawan dia. Okay, dekat number 6 tu dia clockwise moment kan. Dekat join D lawan dia. Okay. So yang ni, yang color hitam semua ni, semua yang color hitam ni, okay, is called as join moment, and join moment is opposite with member and moment. Yang tu yang you have to remember. Okay, join moment opposite with member and moment. Join moment opposite with member and moment. Okay. And then we move to fixed end moment. Fixed end moment. Tadi member and moment tau. Do not get confused. Yang tadi, okay, member and moment. Moment distribution method, when we analyze structure, when we analyze beam, when we analyze frame, using moment distribution method, we are analyzing member and moment. And how to analyze member and moment? Okay, by distribute moment. By distributing moment, okay, and what is the first member and moment in the table? First member and moment that we in distribute, it is come from fixed end moment. And fixed end moment ni dia tak sama dengan member end moment, sebab fixed end moment, as I mentioned, fixed end moment, moment direction for fixed end moment is based on behavior, the behavior due to loading, or the behavior due to settlement, due to delta behavior. So dia bukan sama dengan yang atas, sebab yang bawah ni dia behavior. So yang ni behavior. Allah. Yang ni So please remember yang ni behavior. Okay, fixed end moment behavior. Okay, behavior. So the moment direction based on the behavior. We put moment to counter back. Okay, and then only we compare with the member and moment direction. That is why member fixed and moment we get one negative, one positive. Okay, fixed and moment. Okay, tengok jap yang tadi ni. Okay, member fixed end moment. This is fixed end moment. Okay, fixed end moment behavior. Why we have like this? Why we have like this? Because the beam will bend like this. So the moment will counter back, push back the bend beam to its original position. Okay, and why it is negative and positive? Sini negative, nampak tak? Sini positive. Why it is negative positive? Because we compare with sign convention. We compare with sign convention. Sign convention is this. This is sign convention. Sign convention for MDM. MDM sign convention. Clockwise. Clockwise. But for fixed end moment, we have this. For this load, this is the moment. So when we compare these two, we get it opposite, right? Opposite direction. That is why yang ni jadi negative. And satu lagi sama kan? Dia jadi positif. So yang sama jadi positif, yang different jadi negatif. So that is why we get negative positive. Because we compare with sign convention which is counter which is clockwise. Which is clockwise. Which is clockwise. Okay, when we compare, that is why we get one negative, one positive. Okay? Clear yang tu eh. So we have several type of cases. Okay, basically yang the most popular yang ni number one. Okay, yang selalu ditanya dalam soalan. Okay, yang ni. Yang ni. Yang ni. Yang ni lah. Ni tak. 3, 4 ni tak. Bukan. Okay, 1, 2. And then yang ni 3. And then 4. Triangular load. Triangular load. So yang 4 ni yang I highlight 1, 2, 3 and 4 yang the most common lah, the most common where we can use this 4 to solve problems. Okay, to solve beam or frame problems. Okay, so this is the case where far end roller or pin lah. Or pin. Okay, actually we can analyze beam or frame using only this. Using only this. But if you want to refer to the second formula also can, but you have to understand what's the difference between these two when we apply into the table. Okay, so that is why all the direction remain like this due to loading. Okay, and then due to last formula, last diagram for the fixed end moment is actually referring to settlement. Settlement. Okay, settlement dia macam ni. Segitiga ni, settlement. So this is delta. And moment for this is not same like previous. Okay, yang ni moment is like this. Why we get like this for settlement? Siapa boleh jawab? Kenapa yang atas tadi semua dia punya sign convention macam ni, one negative, one positive. And why for last one ni we get different moment direction. Different moment direction. Why? Why we get that? Siapa boleh jawab? Do you have any idea why the last one due to delta ni, why we have this direction of fixed end moment? Ada tak siapa-siapa nak jawab? After settlement. Remember that fixed end moment is behavior. Kalau tadi dia bend, bila dia bend dia jadi macam ni. So bila you nak apply moment, you have to apply moment, push dekat ujung sini, push dekat ujung sini. So that dia jadi straight, because kalau you salah apply moment, kan? Kalau satu you apply moment macam ni, satu lagi you apply moment, for example, satu you apply moment macam ni, satu lagi you apply moment macam ni. What happened? Dia takkan jadi straight, right? So you have to apply this moment, okay? This moment for FEM due to loading, but cannot be the same for delta. So yang ni delta, Due to delta, you will have triangular. You will have triangular. You will have triangular like this. Okay, you have triangular. Okay, my question is why for the upper one ni, okay, this the purple line is referring to the beam after settle. So why the fixed end moment for the first beam have to be like this? Why? Why it has to be like this? The fixed end moment. Nampak tak difference? The difference in terms of behavior of the fixed of the beam due to loading and due to delta. Dekat sini delta. Cepat, siapa boleh jawab? What's the difference between these two? This one due to loading. Okay, yang ni loading. Yang ni settlement. What's the difference between these two? Can anybody answer? What's the difference between these two?
Satu dia band dekat hujung, satu lagi dekat tengah-tengah. Betul.
Okay, kita apa betul. That is right. Tapi my question is, kenapa moment dekat atas ni dengan moment dekat bawah ni, kenapa tak sama je direction dia ni? Kenapa mesti yang atas ni direction dia macam ni? Kenapa yang bawah ni direction dia macam ni? Dua-dua pun fixed end moment. Kenapa mesti different direction? Yang atas dan yang bawah tak sama. Kenapa?
Pasal yang atas ni beamnya masih straight. Jadi kalau straight selalunya memang moment sebelah turun sebelah naik. Tapi kalau yang bending dia mesti lawan arah bendingnya. Macam tu ke? Rasanya lah.
Okay, sekejap. Nampak saya kan?
Nampak.
Okay, ni eh. Okay, kalau due to loading, tak ada ruler lah pula nak tunjuk. Kalau due to loading, ada buku. Sekejap. So this is all about benda ni. Bila you as engineer, you learn structure, you have to be able to imagine tau. So kalau you tak boleh imagine, susah you nak faham. So you have to try to imagine. Sebab benda ni tak nampak in real, tak nampak dengan mata sebab the displacement pun kan very very small. Bila kita calculate kan dapat 0.0 something kan. Sebab kalau displacement is large, okay, large value, so the structure will be fail. Jadi this we always as engineer always allow certain displacement to be occur in structure, and then that displacement tu is very very small, and we cannot realize it. Kita tak perasan dengan mata kita pun. Okay, yang ni pun tembus juga. Kejap Macam mana tak nak pergi tembus? Ada ruler tak? Tapi nampak kan? Ini straight pula. Okay. Okay, yang ni kan? Yang ni, yang kalau yang atas tu, kalau yang atas tadi tu kan, settlement means dia akan berubah daripada straight macam ni, horizontal, dia jatuh bawah macam ni. Kan jatuh bawah macam ni. Yang ni, yang macam ni, yang ni kan? Yang ni. Okay, dia asal straight. Beam memang position dia original is horizontal. Itu memang behavior of beam. Beam is a horizontal member. Beam is a horizontal member. So original is horizontal. So bila beam ni horizontal member, due to settlement delta tu, FEM due to delta. Nanti kan nak belajar settlement. Okay, due to settlement, dia akan normally settlement ni satu dia masih lagi at same position. Satu je yang bergerak macam tu. So dia akan jadi sengit macam ni lah kan. Sengit macam ni. So tugas fixed end moment, dia nak push beam to its original position. Dia macam konsep you belajar fizik masa tingkatan 4. Konsep inertia, ingat lagi tak? Yang cerita pasal naik bas, lepas tu bas tekan tekan emergency brake. Kenapa kita punya badan tu macam lawan arah dia tu? Sebab nak maintain equilibrium tu. Okey, sama juga konsep ni. So dia mesti go back to its original position. Dia mesti nak maintain in its original position. Bila nak maintain to its original position tu, kat situlah fixed end moment kena bertugas lah, kena bekerja. Dia yang gerakkan, dia yang akan counter back, dia yang akan push dua-dua position, dua-dua end ni so that the beam akan move back to its original position. Kalau dia maintain macam ni, dia lama-lama dia fail lah. Dia mesti akan patah balik. Dia mesti jadi straight balik. Okay, tu fungsi or tugas fixed end moment, counter back. So bila dia jadi sengit macam ni, so apa moment kat sini nak buat? Nak tolak belah mana ni? Atas tolak clockwise ke? Atau anti clockwise, nampak tak? Dia original is horizontal. Original is horizontal. Kalau tiba-tiba beam tu jadi vertical, collapse lah beam tu. Kan? So kita nak maintain safety, kita nak maintain equilibrium. So kita mesti maintain horizontal. Kita nak beam tu maintain horizontal. Jadi for beam after settle, dia settle dekat sini, dia move position, ada settlement dekat sini. So for beam to move back to its original position, kita kena apply moment untuk jadikan dia straight balik, tegak horizontal balik. Bukan tegak vertical. Kita nak jadikan dia vertical balik. So moment yang kita apply tu mesti push dua-dua side ni, A dengan B, push supaya dia jadi straight position. Do you get what I mean? Do you get what I mean?
Faham itu.
Dapat. Faham.
Yes.
Faham ada.
Sebab tu yang ni, yang warna biru ni, moment dia mesti dalam arah tu. Tak boleh arah lain. Sebab kalau contoh dia bend macam ni. Lepas tu you apply moment suka hati. You apply je moment macam ni, lepas tu apply moment macam ni. Kalau beam due to delta, dia punya direction akan macam ni, sama direction. Kalau due to loading, dia akan opposite. Kalau you apply macam ni, you agak-agak yang beam ni, yang merah ni, dia nak jadi vertical, nak jadi horizontal. Kalau kita apply moment color hijau,
Vertical.
dia akan jadi vertical kan? Jadi vertical. So bila dia jadi vertical, what does it means?
Beam fail.
Fail. Okay? So dia sama konsep macam inertia tu yang kita naik bas. Sekarang pun kalau kita naik bas macam tu kan, kalau dalam kereta ke kan, kalau kita brake macam mana? Dia nak maintain equilibrium. So structure ni nak maintain equilibrium je. Sebab kalau kita tak maintain equilibrium, memang fail. Tak maintain equilibrium, fail. Every system, not only structure, whatever structure pun, bukan structure beam only, bukan structure frame only, bukan structure apa lagi? Structure not only building, not only bridge, not only beam, not only truss, not only arch, not only cable. So structure ni kalau kita tengok in ruang yang lebih luas kan, pukul 1 dah ke? Ya Allah, pukul 1 dah. Okey, yang bumi ni pun structure. Dia pun kena maintain equilibrium. So dan dia kena ada support. So kalau tak ada support, dia dah mulalah macam-macam kan. So that is why kat sini kan ada support, ada fix support kan. Bila kita letak support, pasal kenapa kita nak calculate reaction, kita apply equilibrium equation. Sebab semua tu kita buat untuk remain equilibrium. Sebab kalau dia tak boleh remain equilibrium, dia akan fail. So fix and moment tu konsep dia, dalam structure not only fix and moment, we must remain equilibrium. The system must remain equilibrium. So kalau beam is always horizontal member. Kalau dia vertical, kalau kita letak moment salah, dia akan fail. Dia jadi vertical, dia akan fail. Sebab konsep beam dia mesti jadi straight. Dia mesti jadi straight balik kepada original position. So nak jadi original position ni, nak jadi straight balik, we have to apply moment, tolak dua-dua belah supaya dia naik atas balik. That is why fix and moment dia arah tu. Sama juga macam due to loading. Bila due to loading, ada loading kat sini macam ni. Due to loading, dia akan bend. Bila dia bend, nak jadikan straight. Sebab kalau you salah apply moment, what happen? Dia dah bengkok macam ni. Sebab apa kita apply moment, satu sebelah sini, satu yang ni. Sebab bila kita apply moment like this, dia akan jadi straight. Apa jadi kalau kita apply moment terbalik? Apa jadi kalau yang ni kita pergi apply moment suka-suka hati, kita pergi buat macam ni? Jadi apa? Jadi U ke jadi straight?
Jadi U.
So yang ni jadi U, yang ni jadi straight. So yang mana kita nak? Straight. Okay? Kita nak straight. Okay? Kita nak straight. So original position. So kena always remember to remain equilibrium. The structure must go back to its original position. Yang tu baru remain equilibrium. Tu fix and moment. So formula dia tak kisah pun. All formula is given. The most important thing, kita tahu nak apply moment tu and we understand why the direction, the moment direction is like this, why the moment direction is like that. Not because of sign convention, not the one that we need to remember. It is based on the behavior to remain equilibrium. Okay, kita stop dekat fix and moment. Esok kita sambung. Sampai kita buat example lah. Esok kelas pagi pukul 8. Kan, betul kan? Kelas 8 pagi kan, pukul 10?
10
madam.
Pukul 10. Okey. Jumpa esok pukul 10. Okey, kejap. Kita boleh tak on camera for On camera for a while for photo session. Okay, thank you. Tak sempat nak call one by one. Dah pukul 1. Tak apa, kita akan jumpa balik esok. Maybe esok kita akan take time untuk introduce masing-masing lah. Okay, so kejap nak take photo. Take photo kejap. Sekejap. Okay, thank you Nur Atika, Izzuddin, Syuha, Adam, Syafiq Bro, Ikhwan, Zarul hitam je. Okay, Zarul, thank you. Faiz, Hazim, thank you all. Yang lain-lain tu esok Mandy okay, kita sekejap. Kita tukar together mode sekejap. Together mode. Okay. So, gambar sekejap. Okay, 1, 2, 3. Sekejap Lagi satu. Okay, 1, 2, 3. Okay. So kita jumpa esok. Kita akan try to finish at least one example so that lepas tu you dah boleh buat formative assessment and summative 1.1 for topic 1 ni minggu ni. So it is just like formative assessment juga, sama je. Kalau you buat latihan satu and then you buat satu lagi tu summative part of your assignment. Okay, so thank you very much class. We will meet again insyaAllah tomorrow at 10. So we close our session with tasbih, kifarah and surah wal-as. Okay, bye. Jumpa esok insyaAllah.
Thank you, madam.
Thank you,
Thank you, madam.
Thank you,
Okay.
doktor. Thank you, madam.
Okay.